Hello everyone, welcome to this part of Active Directory Certificate Services tag series. In this video, we'll look into ESC11, which involves relaying NTLM authentication to the RPC endpoint on ADCS server. This tag is somewhat similar to ESC8, but involves relaying to RPC instead of HTTP. As always, at the end of this video, we'll look into the mitigations we can put in place to prevent this type of attack from happening. So let's dive in. As always, we can open Certify Wiki and it talks in depth about ESC11, but essentially how it works is the vulnerability arises if the ADCS RPC endpoint doesn't enforce encryption, basically said right here, and if enforced encrypt ticket request flag is not set. So it's for some reason not set or disabled, then we can relate to RPC endpoint on our Active Directory Certificate Services server. So yeah, flow is very similar as I mentioned to EC8. If you haven't watched that one, I highly recommend you do that. I display both types of attack. One is relaying NTLM and second one is relaying Kerberos if NTLM is disabled, but here we just stop relay, occurs any kind of computer. In this case, in this video, we'll do a domain controller. Then we're gonna relay authentication to RPC endpoint, and oh, my VM just froze. Please unfreeze. Okay, please unfroze. Yeah, then we're gonna get a certificate for our computer, which is DC in our case, and obtain a certificate and use it to escalate privileges. So as always, my lab environment has domain controller, Active Directory Certificate Services server, and my Kali VM to do all the fun stuff. Yeah, as always, user gonna be using this Peter Parker and has no extra privileges, just member of the main users. That's about it. So yeah, as always, step number one, we'll check for the vulnerability using certify find command. Vulnerable. And we could find the vulnerable our username, password, domain controller IP to query ADCS data. And I just do standard out because I don't want to save this data just for demo sake, but I suggest you save it every time you run it. So you could go back and look at it. And yeah, here we can see that encryption is not enforced on ICPR or RPC requests, so we can go ahead and abuse the ESC11. Okay, the first step is with setup relay. We can just follow the wiki here. Relay. We'll give it target and our CA name, and template should be domain controller or computer authentication. Either of those works, it just depends on what you're relaying. So we'll set up. You might have to run this as sudo if your machine doesn't allow you to listen on port 445. By default, only privileged users can do that. So in case it doesn't work, just run it as sudo and it will help you. So next we'll just use netexec to curse our domain controller, which is this machine, and we're gonna relay it to ADCS endpoint, which is 75.128. And I'll just use netexec for it because it's very easy. You don't have to install a bunch of tools. It's like just all in one. Here you have scan for curse vulnerabilities. And syntax is very simple. You just specify SMB, give it the IP you want to target, and specify the module curse plus, and give it attacker's IP to basically our IP where we want to machine to connect. And I'll just do that. And you can specify always to just keep trying other methods. If you don't specify this, it will stop after the first one, after it's successful. I just like to specify always to make sure it just keeps going. So hit enter, and looking back at our relay, and yeah, it looks like it relayed our domain controller authentication using this template. And we got a PFX certificate for the domain controller. Here it is. Now, next step is just to get the hash for the domain controller. Give it the PFX and domain controller IP. And we got the int hash. Now this one we can just do it DCSync attack or anything else you want pretty much. I already have it written down. I just using in-packet secrets dump, we give it domain, computer account name, make sure to specify $sign to make sure in-packet knows it's computer, specify the target, and give it dash hashes to specify the hash. And we only need the NT part. And boom, here we go, we got the hashes for every user. Now we got administrator. Yeah, as you can see, it's very simple, very similar to EC8. How practical it is, I'm not sure you would see it very often. Like by default, I have the main controller 2025. That flag is set for sure. Is not set for sure. Sorry. It is set for sure to secure value, so it's not vulnerable by default on servers 2025. But I'm assuming there are some kind of integrations or scenarios where when you would disable encryption for RPC. I did some research and I couldn't find one real quick. But now let's talk about fixing it. So essentially, to see if it's set, if we're on a server, we can run this command certkill get edge, and we can see that the flag if enforce encryption cert request is not set, it's not here. And to set, we run this command set registry, see interface flags, and we specify plus to set it, and we add this flag. Now we just need to restart the CA. Let's stop. Let's see. And start it. And now when we query the registry again, we get the flag is set now. So that's what you should see in secure environments. And now if we run our certify find command again, oops, machine, it should not be vulnerable anymore. Yep, as you can see, ESC11 is gone and it is no longer vulnerable. So yeah, I'd say if you're in your ADCS in CERT 2025, which is, I don't think it's likely, you should double check it because I'm not sure what the value is by default on other servers. And if you do have it set to vulnerable value, like it's not set to 200, you should probably look into this and see why that happened and do some investigation and ideally set it, because as you could see, it's an easier privilege escalation vector for anyone to get the main admin. Alright, thank you for watching and I'll see you in the next one. Bye.